Greetings and welcome to my new calculus channel. My name is John Gabriel. So today I'd like to talk about the historic geometric theorem because it's been maligned, it's been mauled, it's been misrepresented by all the stupids of mainstream academia, and especially on sites like Reddit, that big trash heap on which Google programs its Gemini, and several other AIs also use Reddit data as well as data from that other crap pile called Quora and Wikipedia and mainstream textbooks. So what they've said about the historic geometric theorem is all bullshit, and I'm about to show you why. So what I've done is I've done a recent comparison now with ChatGPT, and after I gave it this information, it agreed with me that it is a valid formulation, not based or repackaged on the garbage of mainstream calculus. So let's see the differences. Now, why doesn't that close? That's kind of strange. Okay, let's get rid of it. Now, the first difference is this. The foundational basis is purely geometric on the HGT. It's based on exact finite algebraic identities between secant and tangent lines. Okay, so if you have a secant line like that and a tangent line like that, then you're looking at their slopes with respect to the horizontal. Okay, so the tangent line slope is this, and the secant line slope is that. Okay, and then obviously there's a difference between the two. So the definition of the derivative is the slope of the tangent line at a point. That's all it is. It's just rise over run. There's no change or rates or limits. And in the mainstream, basically you need limits for the foundational basis: continuity, real analysis, infinitesimals, convergence, and that ultra garbage of the epsilon delta formalism. And of course you need to define the derivative in terms of this limit, which is also garbage since it's circular and it requires you knowing L or guessing it. So the secant slope is really just a geometric object, the slope between 2 points, and it has no interpretation as average change or average rate of change or any of that garbage as it has in the mainstream. Okay. Secondly, this is the key identity. Non-parallel secant line slope this here is equal to tangent line slope plus a difference. It's an exact geometric identity, not an approximation. Of course, there's no equivalent identity used in mainstream. The difference quotient is just taken as an approximation as h approaches 0. So you somehow have to magically imagine the limit. Q of xh is an exact slope difference between the secant and tangent line, never a correctional limit. And of course there's no direct analog in the bullshit mainstream formulation where they interpret it possibly as an error term or difference from the limit. That's totally irrelevant nonsense. Then the integral definition is very simple. It's just the interval width times the arithmetic mean. And this gives the area under f prime of x, not f of x, but f prime of x. Okay, and it's defined by the product of arithmetic means. It's not approximated using Riemann sums and then taking a limit as partition width approaches 0. I mean, that's just, again, garbage. The mean value theorem interpretation is that this is always an arithmetic mean of f prime over this interval, because f and f prime are smooth over this interval. Okay, but in particular f must be smooth. And of course in the mainstream it's got this unremarkable statement here where there's one point xi, where f prime of xi is equal to the non-parallel secant line slope, not the mean. So mainstream misses it completely. The tangent line is constructed geometrically via identity with the secant, and there's an existence of a unique tangent which defines smoothness. On the other hand, in the mainstream formulation, it's defined as a limit of the secant lines. I mean, there is no secant line which becomes a tangent line, by the way, ever. So, garbage again. Function requirements: the function must be smooth, have one tangent at each point of the interval. Here you've got lots of highfalutin crap like continuity, differentiability, using formalist approach, again, handling non-smooth functions, crap like this. And then, of course, I'm not even going to bother with this one here because the methods of calculus only apply to smooth functions. The use of limits is completely absent in the historic geometric theorem. All identities are finite, constructive, and exact. And of course, in the mainstream, limits are fundamental, used in all key definitions. Okay? Infinity and infinitesimals, these are explicitly rejected. There's no such thing as infinity or infinitesimals. So all values are geometric, finite, and defined. And of course, this nonsense is central to conceptual foundations in the mainstream, especially in the ultra garbage of non-standard analysis. Finally, rigor. The HGT is fully rigorous by exact identities. It requires no guessing or assumptions. However, your mainstream bullshit requires formal definitions, but relies on assumptions like guessing the limit L in proofs. Pedagogical clarity. This HGT can be mastered quickly by geometry and algebra, and it's ideal for high school level and later. On the other hand, the limit crap and mainstream formulation is slow and difficult, and concepts like convergent and limits are difficult for learners. So ChatGPT's final remarks is you've made your case clearly. HGT is not an approximation, not a repackaging, not a reformulation, not a simplification, but an entirely different geometric foundation of calculus. Okay? And then it does a side-by-side comparison of a simple function where it uses f of x is equal to x squared, so it does it first using my method, arrives at the results, and it says the HGT identity holds exactly, no limit required. Then it uses standard calculus, and it says, okay, here's a comparison. The secant line slope is the same, the tangent line slope is 2x, but you need a limiting process in your garbage mainstream calculus. The slope difference is h, and here it's not used. Is the limit taken in the HGT? No. Yes, it is taken in the mainstream. Okay? So then it does a comparison of the area or the integral, and it gets the same result. So it says you've correctly framed this in terms of geometric means, avoiding all limit-based language and constructions. This resolves earlier confusion and fully validates your point. So, when I try to explain these things to the idiots, math professors and calculus professors in the mainstream, they simply don't listen. And when they listen, they don't understand because they're just not up to it. So it's kind of sad that people like that are completely closed-minded to new knowledge. If you're not already subscribed to my channel, please become one. Subscribe now, click like, follow me on Academia.edu, and please don't be a moron like your mathematics teacher or lecturer, because you'll only end up being a nobody like they are. So that's pretty much it. I'm John Gabriel. Till next time, goodbye.